All right. Oh, actually it has a wider range now. Wider. All right. So everyone in class 2, I'm just going to explain what this lab is. So this lab consists of 2 parts. The first part is the standardization. And the second part is the titration. The purpose of the standardization is to find out if we actually have a 0.1 molar solution of NaOH. So we should have a 0.1 molar NaOH solution, but we have to verify that. Okay, and how we're going to do that is we're going to use KHP, which is a solid, and it has 1 acidic hydrogen. Okay, 1 acidic hydrogen, and it has a really high molar mass. Its molar mass is 202. It's approximately 202 grams per mole. Okay, so basically what we're going to do is we're going to measure out an exact amount of KHP, and we're going to want to use enough KHP so we get about, so we have to titrate it with about 10 milliliters of solution. So if we want 10 milliliters of NaOH, so we take this 0.1 molar and times 0.01 liters, so that's 10 milliliters. That means we need 0.001 moles of KHP, or because it's a 1-to-1 ratio, there's 1 NaOH for every 1 KHP. 1 NaOH for every 1 KHP. All right, so we're going to need 1.001 moles of KHP to neutralize 10 milliliters of 0.1 molar NaOH, about. It's not going to be exactly that, but we'll see. We're trying to determine what this is, if it's exactly 0.1. That's the purpose. We want to know, is it 0.1 molar? So we need 0.001 moles of KHP, so basically move this decimal over 3 times. So we're going to need about 0.2 grams of KHP. Okay, so what we're going to do is we're going to take approximately 0.2 grams, but we're going to record that mass exactly. So it can be anywhere from 0.2 to 0.25. Doesn't matter. It doesn't really matter. Okay, we're going to take exactly, and we're going to measure that exactly and find out what that mass is exactly. And then we're going to do 3 trials of this. So 3 samples KHP at 0.2 to 0.25, and we're going to add 2 drops of phenolphthalein, which is our indicator solution. And it doesn't matter how much water you add to it. You can add 10 milliliters of water, 50, whatever. It doesn't really matter. I'd probably add at least 10, maybe more than that, of water. Okay. And then we're going to titrate the KHP to the endpoint. Okay. And the endpoint is when it turns pink. Okay. Turns pink. And as you're titrating, you'll have a starting milliliters, and then a final, and then your difference will be your volume. Subtract the 2 final minus initial, you'll get the total volume. Then based on that volume, the volume of NaOH used, and then you're going to take the volume of NaOH used and divide the moles KHP by that. Moles of KHP divided by the volume NaOH will give you the molarity of the NaOH. Because the number of moles of KHP should equal the number of moles of NaOH at that time. You're gonna do 3 trials of that, and then you average it out to find the actual molarity of NaOH. Okay, and usually I think this one is like it's like somewhere like 0.98 or something like that. Not 0.98, 0.098. I don't know though because I added 2 together, so I don't know what it is now. So it could be 0.098, could be 0.095, could be 0.075. I don't know. You have to figure that out. Okay. So that's the standardization. That's basically just figuring out what the actual molarity of the NaOH is. Okay. And then in order to find out the molarity of the HCl, that's the titration. And that one is much simpler than that, what I just went over. So the HCl, we're going to take, so for the second part, the titration, and I don't know if it says acetic acid or HCl. I forgot what I put in the lab, but we're just using hydrochloric acid. Doesn't matter, acetic acid, hydrochloric acid. Doesn't matter. But we're using HCl, and we want to know what is the molarity of that. And in order to do that, we take 10 milliliters of HCl. We're going to measure that. You can just measure that with a graduated cylinder. Sometimes we might do it with an actual burette, but you can just do it with a graduated cylinder. It's fine. And then you titrate that to the endpoint. And don't forget to add your indicator. 1 to 5 drops of phenolphthalein. And that's the whole lab. Okay, we kind of did a titration before. So we kind of did a titration before with the burette, right? But we did a oxidation reduction one. This is acid-base titration. We did a with the hydrogen peroxide. You remember? Just remember when you're filling the burette, you want to rinse it first with whatever you're titrating. These are clean right now, so you don't need to rinse it with water. But you just rinse it with a little bit of whatever you're titrating. Let it all drain out, and then put your new titrant in there. So you're going to be filling this with NaOH. Okay. All right, and then you can use the stir bar things and the stirs if you want. You don't have to. Any questions? All right. Let me stop this recording.